Good morning, students. Up to now, we have completed exercise 3C in playing with numbers chapter, and now we are going to learn a new concept which is highest common factor HCF and this is also called as greatest common divisor GCD. Greatest common divisor, both are same here. Highest common factor or greatest common divisor, both are same here. And also you are going to learn the lowest common multiple, which is also called as LCM. These two concepts also learned in your previous class also, and again you are going to learn these the different methods. Three methods are there for each and every concept. For highest common factor, three methods, and LCM, three methods are there. Okay. So now before going to learn about these HCF and LCM, I would like to revise some concepts which is common factors and common multiples. Already I explained in the previous classes. Once again I would like to explain the common factors and common multiples. Okay. So now see here what are the common factors. Common factors. Common factors. What are the common factors? I am going to take two numbers 12 and 36. Okay, you all of you know how to find out the factors of the given numbers. So for 12, first we will take 1 and 12 are the factors of this number 12, and next we have to try with divide with 2. So 2 6 are 12. Okay, next one try with dividing with 3. So 3 4s are 12. Okay, next one, there is no number in between 3 and 4. So 1 2 3 4 6 12. These are the factors, normal factors of the 12 here. Okay, next for 36 it is 1 comma 36, 2 18s, next 3, how many times? 12 times, 4 9 times, and 6 6 36. Okay, and there is no other number. So 6 you can write only one time because it is a factor you can write only one time. So 1 2 3 4 6 9 12 18 36. These are the factors of the 36. Now if you observe both the lists of factors of 12 and 36, in these two lists, which numbers are occurring two times? Here observe here which numbers are occurring in the both the lists, you have to observe. Those are called as the common factors. That number should be in this list and that should be in the second list also. Those numbers are called as the common factors for both 12 and 36. So here 1 is occurring in the both the lists, 2 is also there in the both the lists, 3 is also there in the both the lists of the factors of 12 and 36, and 4 is there, 6 is also there, and 12 is also there in both the lists of factors of 12 and 36. So these 1 2 3 4 5 6, these 6 factors are the common factors of 12 and 36. This 1 2 3 4 6 and 12, these 6 factors are the common factors of both 12 and 36 because they are occurring in both the lists. Okay, so in these common factors, 12 is the highest factor. 12 is the highest factor and common factor, highest common factor. So this itself is the HCF. Okay, finding out the highest common factors finding out the highest common factors, this is also one of the method. Okay, that is called as the factorization method. So this method you can use to find out the highest common factor also. Okay, just I told you how to find the common factors here. From this you can find out the HCF also like this. So this is one of the methods you can use to find the HCF also, highest common factor. Out of all the common factors, if you choose the highest factor, that itself is the highest common factor or HCF of 12 and 36. Okay, next one, common multiples. Common multiples. Okay, multiples means you have to take the multiples of the given numbers. Common multiples. For example, 3 and 6 I am taking. Okay, so multiples of 3 means 3 table only. Okay, 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21, 3 8s are 24, 3 9s are 27, 3 10s are 30. Like that you can write any number of multiples. Multiples are infinite. Okay, next take the all the multiples of 6. 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30, 6 6s are 36. Like that you can write any number of multiples like this. Okay, these are the list of multiples of 6. These are the list of multiples of 3. Out of these two lists, which numbers are common or occurring in the both the lists, we have to choose. So this 6 is occurring in the both the lists, 12 is also is there in the both the lists, 18 is also there in the both the lists commonly occurring, and this 24 is also is there in the both the lists, and 30 is also there in the both of the lists. Both of the lists of the multiples of 3 and 6. Like this you can find infinity number of common multiples for both the numbers. Okay, out of these lists of common multiples, what are the common multiples here occurring here? 6 here, 12, 18, 24, 30 and so on. Okay, like this infinity number of common multiples will be there for any two numbers. Okay, so now here out of these common multiples, lowest one is this one. Okay, this is called as lowest common multiple, LCM. Okay, like this also you can find out the LCM, lowest common multiple of any 2 or 3, any number of numbers you can take. Okay, you can find out the lowest common multiple by using this method also. But this method is a very lengthy method, that's why we will use another methods generally, but this is one of the methods which is called as the factorization method. Okay, after finding out the multiples, not factorization, after finding out the multiples we will choose the lowest common multiple amongst all the common multiples. Okay, like this. So this is the concept of common multiples and common factors. So by using this we will learn the 3 different methods. So which are the to find out the HCF here. First one is factorization method, already we learned now itself, and the second one is prime factorization method, finding out the only prime factors of the given numbers we can find the HCF, and the third one is the long division method. Okay, once again you see here factorization method here. I am taking one example. Find the HCF of 24 and 32. So take all the factors of 24 which are 1, 2, 3, 4, 6, 8, 12, 24, and all the factors of 32 are 1, 2, 4, 8, 16 and 32. So out of the list of all these factors, so 1 1 is the common factor, and 2 2, 4 4, 8 8, these are the common factors of 24 and 32, 1 2 4 and 8. Out of these 4 common factors, 8 is the highest common factor. If you observe, 8 is the highest common factor which is having a highest value. So thus the highest common factor of 24 and 32 is 8. So like this you can find out the HCF of two numbers by taking the lists of all the factors and finding out the highest of among all the common factors. Okay, this is the first method. It's very easy, but we have to find out all the factors first. Next, common division method with prime factors. This is also called as the prime factorization method, but we will divide both the given numbers. We will divide both the given numbers with a common number, with a common factor. That is also common prime factor only we will take. Okay, using that we will divide both the given numbers. So if you take 36 and 192 and divide this with the first prime number 2, so I will explain this in the next screen. See here, 36 and 192. Okay, 36 and 192 I am taking. So divide both the numbers with a common divisor or common factor, which is also a prime number also. You know what is a list of prime numbers. So 2, 3, 5, 7, 11, 13, these are all the prime numbers. At least you have to know up to 6 or 7 prime numbers, first prime numbers, because you have to choose first, you have to choose the first prime number 2. Okay, and that should be these two numbers should be divisible by 2 first. Okay, if it is divisible by, both the numbers are divisible by 2 only, you have to choose 2 first, otherwise you have to choose 3. Okay, if these two numbers are not divisible by 3 also, then you have to choose the next number 5. But the condition is both the given numbers should be divisible by taken prime number. Okay, whatever the number you are choosing here, that number should divide both the numbers. Okay, observe here, the last digit is 6 here, last digit is 2. So these two numbers can be divisible by 2 by the divisibility rule of 2. So I am dividing this with 2. So 2 18s here, 2 9s are 18, 2 6 are 12, 96 times. Again it can be divisible by 2 because the last digit is 8 here, here it is 6, 2 4. What is the rule here? 0 2 4 6 8. If the last digit is or one's place digit is 0 2 4 6 8, that number is divisible by 2. So here 8 and 6 are there here. So here also you can use 2, 2 9s are 18, here 2 4s are 8, 2 8s are 16, 48 times. If you observe here 9 is not divisible by 2, but 48 is divisible by 2. So you cannot choose 2 here, because both the numbers should be divisible by 2, then only you have to choose 2 here. Now go to the next number. So is it this 9 and 48 is divisible by 3 or not? 9 is divisible by 3, 48 is also divisible by 3, because the sum of the digits 4 plus 8, 12 is divisible by 3, so this is divisible by 3. So divide this with 3, 3 3s are 9, here 3 1s, 3 6, 16 3s. Okay, so now this 3 and 16, both the numbers are not divisible by any of these numbers. Okay, both the numbers at a time not divisible by any of these numbers. It is not divisible by 3, these two numbers at a time not divisible by 3, not divisible by 5, 7, 11 or anything. That's why you have to stop here. You have to take these left side numbers only. Okay, these left side numbers only have to take and multiply. So 2 into 2 into 3, 4, 2 2s are 4, 4 3s are 12. So this is the highest common factor of both 36 and 192. The most important thing you have to remember here, this is you are finding out the HCF by using the prime factorization. Same method you can use to find out the LCM also, but there you can continue if both the numbers are not divisible by the given prime factor. Okay, if it one of the if one out of the two is also divisible by the given number, you can continue. But in the HCF, you should not continue. If both the numbers are not divisible by the given factor, you should stop there. Okay, you have to take up to here. But in LCM, you have to continue up until you get all ones in the last row. And you can continue if it is divisible by, if any one of the numbers are divisible by the given factor, then also you can continue. For example, I will show you the same problem for LCM. Here it is, if it is divisible by 3, one of the numbers, you can continue. 3 ones are 3 and the remaining you have to bring down. Okay, if it is not divisible by the 3. And this 16, how many times? You have to take 2 here because it is divisible by 2. So 2 8s. Next again bring down this 1 again, and 2 4. Bring down this 1 here and divide with 2. 2 2s are 4 and 2 1s are 2. So these are the prime factors. Until you are getting 1 1 in the last row, you have to continue like this. If it is LCM. But in HCF, you have to stop here only. You should not do this procedure. That you have to remember. That's the main difference in between finding the HCF and LCM. Remember, all of you. Okay, now you are finding out the HCF only. Since both 3 and 6 are not divisible by any of these prime numbers at a time, you have to stop here. Okay, and you have to take only up the factors up to here only, which are 2 2 3 and multiply 2 into 2 into 3, which is 12. But for in LCM, you can continue up to until you get the 1 1 in the last row. Okay, that's the main difference. So here I wrote, since here there are no common factors for 3 and 16, we stop here and you take 2 into 2 into 3, which is 12, which is the HCF of 36 and 192. And I wrote a note here, when we are finding the LCM using this method, we will not stop even there are no common factors to divide all the numbers and continue the process till we get all ones in the last row. Okay, that's what I explained. Okay, next one. In the third method in this finding out the HCF is long division method. First one is the factorization method. Next one is this common division method with prime factors. Common division method with prime factors. Next one is the long division method. See here, long division method is, it is a normal division method only, but you have to use some laws. Okay, find the HCF of 24 and 36 using the long division method. Same numbers I am taking, 24 and 36. So first you have to divide the bigger number with the smaller number. So 24, how many times it divides? Maximum 1 time. So 24 ones are 24. So whatever the remainder you are getting, take this remainder as the divisor, and again this divisor, first divisor you have to take as dividend and divide again. Okay, this 24 you have to take here again and divide this with 12 again. So 24 12 twos are 24 and you are getting 0. Until you get this 0 like this, you have to continue this process, same procedure. For example, if you are getting any remainder here, some 3 or 4 here, you have to divide this 12 with 4 again, and so you have to continue that like that. Okay, since you are getting 0, you are stopping here. Okay, so this is the method. So wherever you are getting 0 here, this divisor is called as the highest common factor of both the numbers 24 and 36. In the last step, where you are getting the remainder as 0, that divisor is called as the HCF of the given 2 numbers, okay, or 3 numbers, whatever it may be. This procedure will be continued for 3 numbers also. How can you find out for 3 numbers? After getting the HCF of the 2 numbers, take this HCF and you have to divide the third number with this HCF. Okay, until you get the 0, you have to continue that. Okay, I will show you that one also. The example here, find the HCF of find the HCF of here 36, 48, 96. Okay, how to find the HCF? First you can take these two numbers. Okay, otherwise you can take these two numbers also, whatever it may be you can take. Okay, first I am taking 36 and 48. So 36 divides the 48 one time maximum, because 2 times is 72. Okay, here it is 2, here 1. Now we have to divide this 36 with remainder 12. 12 3 is 36, 0. So now we are getting remainder 0. So this is the HCF of these two numbers, up to these two numbers, 36 and 48. Now we have to divide the third number with this HCF 12. 12, how many times maximum? 8 times. You know, 8 2s are 16, 8 1s are 8 plus 1, 96. So 12 8s are 96. Directly you are getting 0 here. So 12 itself is the HCF for all the three numbers. You can continue this procedure if 4 numbers or 5 numbers also given. This procedure will be continued for 4 numbers and 5 numbers. If another 4 numbers also, another 4th number or 5th number also given, you have to take this HCF and divide that with this HCF. Okay, so this is the procedure. Next one, so this is called as the long division method. Okay, so next, lowest common multiple or LCM. Lowest common multiple means already I told you what is the lowest common multiple in the previously. So which is the first method itself, finding LCM by selecting lowest common multiple out of the list of all common multiples. Okay, that is the lowest common multiple, finding out the list of common multiples. Next one is the prime factorization method. Here also prime factorization method you can use, and common division method with prime factors. This is similar to the HCF, finding out the HCF. Already I told you while I am explaining the HCF. Common division method with prime factors. But here we will continue up to we are getting 1 1 in the last row. Okay, so see the first one. This already I explained you. First find the LCM of 4 and 6. Here I am taking 2 numbers only. Okay, first I am taking the list of all multiples of 4, which are 4, 8, 12, 16, 20, 24, 28, 32, 36. How you are getting these numbers? These are the 4 table numbers only. 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, like that. Okay, next. Multiples of 6 means 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30, like that. You have to take all the multiples. Multiples of infinite in number, any number you can take. Okay, so now observe here which numbers are common in both the lists here. This 12 is there, next 24 is occurring in the both the lists, next one is here 36 is there, 12, 24, 36 and so on numbers are there. These are the common multiples of 4 and 6 up to now. Out of these three numbers, 12 is the lowest common multiple. Lowest common multiple. Okay. So like that you can find out the LCM of the given 2 or 3 or 4 numbers. Any numbers of any number of numbers you can take. You have to find out the list of all the multiples, and then amongst the list of all the common multiples, you have to take the lowest one, like this. Simply you have to take the lowest one. So that is the lowest common multiple of the given number. So this is the first method, which is called as the finding LCM by selecting lowest common multiple. Next, prime factorization method. So here prime factorization method means first you have to take the prime factors for the both the numbers separately. You cannot divide the numbers commonly, like common division method. That is another method, third method. Here you will divide both the numbers separately with the prime factors only, with the prime numbers only. How to do? That's why it is called as the prime factorization method. So 2 8 is 16. First prime number is 2. What is the next prime number? 3 5 7. Like that you have to choose. Okay, if it is not divisible by 2, then you have to go to for next number. First of all, you have to choose 2 only, because this is the smallest prime number. So 2 8 is 16, 2 4 are 8, 2 2 are 4, 2 1 are 2. This is over. After getting 1, you can stop here. Next 2 10s are 20, 2 5s are 10. Now you can divide this with 5 only. So 5 1s are 5. So write the lists of all the prime factors of 16 and 20 like this. 2 into 2 into 2 into 2 like this. Next 2 into 2 into 5 like this. Now you have to take, you have to round up which are the common factors of both the numbers. Which are the common factors of both the numbers you have to round up. Which are occurring in the both the lists of factors you have to round up. Okay, maximum two times if they are occurring, you have to round up them. Okay, here 2 times 2 numbers are there, round up. Out of these two common factors, you have to take only one factor, which is 1 2 only you have to take. Out of these two also you have to take only 1 2 here. Remaining numbers which are not common factors, you have to take them as it is. Remaining numbers which are not common in the both the list of the factors, you have to take them as it is, like this. 2 here, 2 4 5. But which numbers are occurring in the both the list of the numbers commonly, you have to take out of two common factors, you have to take one. For example, if you are taking the common factors for 3 numbers, and in the both the list of the factors they are occurring 3 times like this, you have to take only one out of those 3. Here only 2 numbers, that's why 2 out of these 2 you have to, out of these 2 1 only you have to take, 1 out of these 2 you have to take, 1 out of these 2 you have to take. Okay, so 1 2 you have to take here, 1 2 you have to take here. Here remaining all the numbers you have to take and multiply. 2 into 2 into 2 into 2 into 5. Okay, by multiplying you will get here 80. So this is the LCM of the given numbers 16 and 20. This is one of the method and longest method. This method generally we will not use while we are doing the LCM problems. We will use the next method only, next common division method only we will use, but you have to learn this. Okay, so this is the finding out the LCM of 16 and 20 by using the prime factorization method. Next one, common division method with prime factors. So this is also prime factorization method only, but you are dividing both the numbers with the common factors, both the numbers at a time. Here you are separately taking, here you are dividing both the numbers with the common factors at a time. Okay, now first prime number is what here? 2. Again same numbers I am taking. 2 8s are 16, 2 10s are 20, 2 4s are 8, 2 5s are 10, 2 2s are 4. Here you cannot divide this 5 with 2. Even though you are not able to divide this with 2, you have to continue this process by bringing down that number simply. So 5, same number you have to bring down. Now you can divide this 2 with 2, 2 1s are 2, and this 5 again you are bringing down. So now this is 1, already 1. So now you can divide this 5 with 5. So bring down the 1 here and 5 on the 5. Now you are getting all 1s. Until you get the all 1s in the last row, you have to continue this process. So now you take all the left side numbers 2 into 2 into 2 into 2 into 5 and multiply, you will get 80. So same number you are getting which you have got in the previous one. Okay, same answer you are getting. Here also 80, here also you are getting 80. So but this method is easy for you. Okay, this is This is only you have to use while you are solving the problems in the word problem. So common division method with prime factors. This is very important method, and this I am explaining for 4 numbers also. Here it is 2 numbers only. So you can continue this method for 3 numbers, 4 numbers, or 5 numbers. So 2 6 are 12 here. You cannot divide this 15, so bring down. This is 2 10s are 20. You cannot divide this 27 with 2, so bring down as it is. So now again 2 3s are 6. Bring down 15. 2 5s are 10. Bring down 27. Next, maximum 3 numbers can be divisible by 3, so you can choose 3 here, and 5 is not divisible by 3. You can bring down this. So why we are choosing 3 here? Any one of the number is not divisible by 2 here. That's why I am taking another prime number 3 here. Okay, 3 1s are 3, 3 5s are 15. Bring down 5, 3 9s are 27. Here maximum 2 numbers are divisible by 5, that's why I am choosing 5 here. You can choose 3 also. I will take 3 later. Bring down the 9 first. Next 5 1 here, bring down the 1 here. Next 5 1s are 5, 5 1s are 5. Bring down 9 here. Next, since 9 is divisible by 3, we are taking again 3 here. Bring down all 1s here. 3 3s are 9. Again bring down all 1s here. 3 1s are 3. So now you got all 1s in the last row. So you can take all the prime factors you are getting in the left side. 2 into 2 into 3 into 5 into 3 into 3. So by multiplying all these numbers, you will get 540. 2 2s are 4, 4 3s are 12, 12 5s are 60, 60 3s are 180, 183 is 540. Like that you have to multiply. So this is the lowest common multiple of all these 4 numbers. So like this you have to find out the LCM. Okay, so these are the methods you will use to find out the both HCF and LCM. So in the next session, in the next class, we are going to solve the problems in exercise 3D. Up to now I am going to stop this session. Good day to all of you.